Hello friends and welcome to Edupedia World Videos. This is the course Basics of Programming in C language, and right now we are doing chapter 15 part A, file handling in C language. Okay, so till now we have covered a lot of topics including pointers and all. Now ultimately we are going to learn something about file handling. So first of all, what is file handling? Well, why do we need file handling? To permanently store any data on the computer, we can write it into a file. Okay, so till now whatever we have done, our programs read some data, took some input from the user and then displayed the output. But when the program used to close, okay, whenever we used to close the program or program used to exit, the data that we had entered into the program could not be retrieved anymore. It was not available anymore because it was stored in the volatile memory or the RAM, random access memory, which is a temporary memory. So that data will remain in the RAM only for the time being when the program is being run. As soon as your program exits, all its data, whichever is stored in the RAM, is deleted. So suppose you want to store some data permanently in the computer. Suppose you want to make a software to maintain the record of books in a library. For this kind of a software, you don't want that when in the evening the computer is shut down, your data should not be available the next morning. Okay, so all of the data that you have entered today should be available for years and years to come. So for this kind of data management, you need some place to store the data permanently. So we generally write down the data on the hard disk. So on the hard drive, when you write down the data, you have multiple options. One of them is using basic files. Okay, so we will be covering the files only in the basic course, and otherwise the other options are to use a database. Okay, so what is a database? Database is another software. Okay, it is an application software that helps you to manage your data. Okay, you can store your data in the database and you can search for your data applying various filters. So all these kinds of facilities are provided by the database, so it makes your data access very fast. But right now we are concentrating on writing our data into a file. Okay, so in C language, the process of creating files and writing into file or reading from file, all these things form a part of your file handling. We can write either plain text files or binary files. So there are two kinds of files that you can write. Okay, ultimately everything, so we have to understand that ultimately everything that is written into a computer is in form of binary code. Okay, but we will understand the difference between plain text files and binary files in the following slides. Okay. The file input function and output functions are declared in stdio.h. So this is the header file in which file input and output functions are declared, and standard input output.h, stdio.h, we have already been using in all our programs because this is the file in which your console input and output functions are also declared. So printf, scanf, all these functions are also declared in this file only. So we have already been using this file and we are familiar to this header file. Okay, so the file is accessed using a file pointer, okay, which points to the next location to be read from the file. So whenever we have to access a file, we have to declare a file pointer, okay, which is a variable of the data type capital all in caps file, file. Okay, we will read about it later on. So we have to take that pointer first of all, and this pointer will always point to the next available location inside the file to be read. Okay, so this is a basic file handling process that we are seeing on the screen. The first thing that you have to do is to open a file. Okay, whenever you have to read a file or write a file, you have to first open the file. Okay, so we have a particular function for opening the file which we will call. In this function we will pass the path of the file. So now what is the path of the file? The path of the file is mentioning the exact drive, that is your C drive, D drive, whichever partition of the hard disk your file is on, you have to mention that particular partition, and then the folder in which that file is contained, and then the name of the file. Okay, so then After opening a file, you can either read from the file or write into the file. Okay, you can also seek, that is, you can go forward or go backwards in that file. Okay, and at last you have to remember that once you're reading and writing, once your task is over, at last you should always close a file inside your program, otherwise it will always remain open. And suppose if you are reading hundreds of files inside the same program, then hundreds of files will remain open if you are forgetting to close them. Okay, this will cause issues with your memory, and moreover the operating system also limits the number of files that one single process can open. So in case the operating system has imposed a limit of 1000 files for one program, and you are not closing the files but opening more and more files, when your program reaches the 1000 files threshold mark, it will then not be able to open any more files and it will cause errors. Okay, so you have to keep in mind that you close all the files when you are not needing them anymore. Okay, so now this is the difference between a binary file versus a text file. Okay, so first of all, what is a file? A file is just a series of bytes, one after the other. Okay, so it is nothing but a series of bytes. When you open a file, if you just read it in the machine language form, as in the form in which it is stored inside the computer hard disk, it is nothing but a sequence of bytes. Okay, 01100110, and that is how it is. Okay, so that is numbers between 0 and 255. So bytes are nothing but numbers between 0 and 255 in the hexadecimal format. Okay, so with this definition, all the files are binary files. That means that all the files are nothing but binary files. Okay, they store nothing else than binary numbers or bits, 0 1 1 0. So whenever you open a plain file from straight away from the operating system in its machine language, you will be able to see only ones and zeros. So what is a text file then? Well, a text file is a file that only contains the hex codes. What is hex code? Hex code is a hexadecimal representation of a number. So when you read about binary number system or the Boolean algebra, you will read about various number systems. One is the decimal number system that we use in our daily practice. Okay, 0 to 9, there are 10 digits, and combination of these digits will form various other numbers. So that is the decimal number system that we are all are familiar to. Apart from this, there is a binary number system in which there are only two digits, 0 and 1, and all the other numbers are formed out of these two digits. Then there is one octadecimal number system in which there are 0 to 7, 8 digits. Okay, and all other number are formed from these digits. And here we are talking about the hexadecimal, the other kind of number system in which there are 15 digits. First is 0 to 9, and then there are alphabets from A to F. Okay, so 0 to 9, after 9, instead of 10 there is A, then B, C, D, E, F. So 15 in decimal is F in hexadecimal, and then these numbers repeat. Okay, so you can read about Boolean algebra in detail if you want to understand this thing, but to understand this particular tutorial, you don't need to go in that much into detail. We are just discussing that a text file is that file that contains only the hexadecimal codes, hexadecimal values of readable characters. So we have also discussed earlier that inside C language, the characters, that is A to Z, or small a to small z, capital A to capital Z, or 0 to 9, and even the special characters like comma, question mark, greater than sign, brackets, asterisk, all these are stored in terms of hexadecimal characters known as their ASCII values. So there is a complete ASCII table. Okay, so you can refer to that table online, and there you will be able to find the decimal codes for all of these values, and when you convert those decimal numbers into hexadecimal numbers, you get their ASCII codes. So these ASCII codes are the ones which are actually stored into the files. So a text file is a file that contains only the hex codes or ASCII codes of the readable characters. Okay, special characters or white spaces or new lines. So only these characters are there inside that file. So when you open that file in a normal text editor like Notepad, okay, you will be able to read whatever is written into that file, because a text editor like Notepad will interpret every value as its ASCII value. But for more complex application programs, word processors like Microsoft Word, this is not true. Okay, because Word will contain other information also, like formatting. Some text is in bold, some text is in red color, some text is in white color, some background is changed, some picture is also there. So they contain something which is apart from the text also. Okay, so these are the various things which are stored inside not only your word processors like Microsoft Word, but your other programs like Paint. Okay, they create image files. So these are also binary files, not text files. When you open a image file inside your Notepad, you will not be able to read anything. Okay, so these kind of files are binary files, but plain text files are those files which contain only readable characters. We open them in a Notepad and you can straight away read whatever is written into them. So in C language you can create both these kinds of files. So if you want a file that is human readable straight away, so you will create a text file. But if you want an optimized file in a format that otherwise is not readable but is readable only when using your program, like the Microsoft Word, a doc file is only readable when you open it in Microsoft Word. Okay, so in that case you will be using a binary file. Okay, so further there are some more differences given, some of which we have already discussed. Okay, so the binary information which we have stored in a binary file, it is only readable by a computer program and understandable by a computer program. The logic that is programmed into it will be able to decipher it and read it and then show it to the user in a readable form. But in a text file, you can just straight away open it in a text editor and it will be readable. Okay, so these are various file modes that in which you can open a file inside a C program. So we will learn about these modes, how to use them later on. First, let us read what various modes are available. First is read only mode. So if you want that you should be able to read from a file, okay, and you don't want to accidentally update any information into that file, so you can open a file in a read only mode using the R option, small r. Okay, so it will mean that you will be able to read from the file but not write anything to the file. Then there is a write only mode using the W option. Okay, so using this W you can only open the file in a write only mode. It will not be opened in a reading mode. Apart from that, there is an append only mode. So append only is also that you can only write into the file, but the difference between W and A is that in write only mode it will start writing from the beginning of the file. So if your file already has 10 lines in it, it will write from the first line onwards. So it will overwrite first 10 lines. Okay, so whatever information is already there will get overwritten. But if you use append only mode, it will not get overwritten, but it will go to the 11th line and then write from there onwards. Okay, so that is the difference between write only and append only. So in write mode it start writing from the beginning of the file, overwriting any information which is already there. But in append mode it will not overwrite any information, it will go to the end of the file first, passing all the already written information, and then at the end it will add some new information whatever you will write. Then there are other options like read plus write mode. In you can use this mode by using R plus or W plus, whatever you can write both of these values, either R plus or W plus. So in that mode you will be able to read and write. And there is a append plus read mode which is A plus. So if you use A plus, then if you will write any value it will get written at the end of the file, and if you are reading any value you will also be able to read from that particular point. Okay, so for binary files these modes are different. The earlier modes that we did were for text files. For binary files the only difference is that you have to append a small b alphabet after the mode. So RB, WB, AB, RB plus, WB plus, AB plus. So these are the modes for binary files. So if you use RB, by default the compiler will understand that the file that you are using is a binary file if you use a B. But if you do not use a B, the compiler will understand that you are using a text file. Okay, so now the file handling functions. So there are a few functions that are given to us in stdio.h which are used to handle files. The first is the function to open the file, fopen. So, okay, what it will do is it will create a new file or open an existing file as per the specified mode and specified file name. Okay, fclose is a function that closes a file. Then getC is a function to get a character from the current position in the file. Okay, similarly putC will write a character to a current position in the file. fscanf is nothing but analogous to scanf for console. Okay, so like scanf we have for console, fscanf we have for file. So we'll pass a file pointer to it and we will pass some format specifiers, and then we will pass a variable to which the read value will be stored. Okay, similarly fprintf is contrary to the printf statement that we have for console. We have fprintf for file. Getw or getWord is to read a word or an integer from a file. By integer is referred to as a word. Okay, a byte is always 8 bits in length. Okay, but a word for a 32-bit machine, a word is 32 bits or 4 bytes in length. Okay, but for a 64-bit machine it is 8 bytes in length. Okay, similarly putWord is to write an integer to the file. Then there is fseek. What is fseek? Fseek is if you want to go forward or backwards in a file. Okay, you can just give a position value to that. So all the positions, when you open a file, your compiler will generate, your program will have a reference to the file locations. Okay, your file will be loaded into the memory, and all the memory locations which form a part of your file will be available to you. So you can go to any of these positions by passing the value into the fseek function. And similarly the ftell is just the opposite of it. It will tell you the current position. Okay, so whatever it returns is an integer, whatever you pass to it is also an integer. You pass an integer value to fseek and it will go to that particular location in the file, and when you do ftell it will give you the current location of the file. What is rewind for? Just like in your media players, rewind will take you to the first location in the file, so it will set the position to the beginning point. Okay, so these were the functions. Now we will do these functions depending on the file operations. So corresponding to the file operations we have these respective functions. We have 4 operations that we can do in a file. First is the open a file. So for opening a file we have fopen. Then you can read or write to a file, you have these functions: getC, putC, fputC, fgetC, fscanf, fprintf, getw, and putw. Similarly you have seek operations that you can do on file. You can go back, you can go forward, you can go to a particular position in the file, you can rewind the file to the first position. So all these functions will help you do that: fseek, ftell, and rewind. And at the end, when you have done the processing on your file, you must close the file. Okay, for that the function is fclose. Okay, so using the fclose function you can close your file at the end. Now about the file pointer. So what is a file pointer? We have already discussed that whenever we will open a file we will get a pointer to the file. So using this pointer you will perform the operations, whatever operations you want to perform to the file. So in C language, on opening a file, the function that we call is fopen. It returns a handle to the file. What is a handle? A handle is to the file is something that lets us to refer to that file. Okay, this is also known as the file pointer. So we use this pointer throughout our code to perform operations on the opened file. So how will you tell that okay you have to read from which file you have to read? So to tell the computer that read from this file we have to pass the file pointer. Okay, so this is an example how a pointer is declared. This is declared using a data type file, caps, all letters in caps. You have to write file. Okay, and then you have to give the asterisk sign because you have to always declare a pointer to it. Okay, star file1, this is the name of your variable. You can take it to take any name you want, then equal to fopen. The function you have called over here is the function to open the files. After that, you have to give the file name, so it can be any name along with the absolute path, the complete path of the file. Okay, so if your file is in C directory in a folder named directory, so you will give C colon then directory and then slash and then the name of your file. Okay, similarly after that you will have to give the mode. So what will be the value of mode? It will depend on whether you want to open your file in read only mode or write only mode or read and write or append mode, whatever. So that particular value which we did in a few slides back, R, RW, R plus, all these values will come over here. Put C, then you have to perform any operation, you will pass the same pointer that you have declared over here. So if you want to write a character a, small a, to the file, you will pass the file pointer over here in these functions. Okay, so a file pointer always points to the next location of the file to be read or written. So whenever you read from a particular location, your file pointer always starts pointing to the very next location of the file. Okay, we will also see this in a very well illustrated animation in a few in a slides in this slide. Okay, so now this is a graphical representation of a file pointer. So just assume that this whole area is your computer's memory, and on that we have a various memory blocks, and in these memory blocks we have stored a file. In this file there is a string hello, then there are two white spaces, and then there is world, and then there is a full stop, and then a new line. Here your line is ending. Okay, so when you call the function fopen to open this file in read only mode, what will happen is you will get a pointer to the first location of this file. Okay, so you got a pointer to the first location of this file, which is pointing to the first character, that is H. Now what you have to do is you have to read a character from this file, so you will call the function get C, and you will pass the same pointer that you have declared over here. So you will pass the same pointer to the get C function. Once you pass the same pointer, so what will happen is it will read the character whatever is written at that particular location of the file, and it will also move the pointer to the next value. Okay, so it reads the character and moves the pointer to the next location of the file. Now again, suppose if you call get C function, again it will read the next location. Okay, it will give you the value whatever is stored in the next location, it will read that and give it to you, and then move the pointer to the next location. So this will keep on continuing. Okay, apart from this, when you call rewind, okay, what will happen is it will take your pointer to the first location of the file. Okay, so all these function calls, in all these function calls we are passing the pointer to the same file that we have declared earlier. Okay, now let's see some other example. We are now using the function get s. So what does get s do? It reads a whole line from your file. So how does it come to know that your line has ended? By the new line character, and new line character is nothing but \n. That is the escape sequence for new line in C language. So suppose the new line character is over here. So when you call gets file, what it will do is it will first navigate to the last of the file. It will not stop till it finds the new line character. Once it finds the new line character, then it will return all the characters read, okay, including the new line character, to your program. Okay, so this string hello world that it has read, hello, two spaces, two white spaces, and then world and then full stop, will get returned to your function, to your column function. Okay, so then when you call the fclose function on the same file pointer, it will just close the file and you will lose the reference to that file. So now after calling fclose on file 1, you will again not be able to read anything from this file, because now you have closed the pointer and your pointer points to nowhere. Now if you try to read anything, you will get a null pointer null, the pointer will be null, and you will get an error and your program will terminate. Okay, so I hope this basic information on file handling was clear to you. This was just a theoretical part. We will do the practicals in the forthcoming videos. Okay, thanks for watching this video and continue to watch the course Basics of Programming in C language. Thank you.